Last video, we talked about how students often have difficulty really relating concepts together in statistics. And this turns to add a lot of confusion because they're really unsure where one thing begins and how it's related to the next. And instead, they just perceive these things as completely different concepts and different equations that are unrelated. And it makes it really difficult for them to understand the bigger picture here. So we're going to talk about how we go from our x observed values all the way down to our p-value. We're going to do this using a t-test. So the first thing we're going to have to compute is our mean. The second thing we're going to compute is our standard deviation, but here we're going to note it as an s, not an SD like we did before. Then we're going to use our t-test to get a t-score, and that's going to be able to lead us to our p-value. So we're going to start with our x and we're going to go to the mean, which then we're going to use to get our standard deviation. Then we're going to use that to get our t-score. Then we're going to use that to get our p-value. So I'm going to draw the equations out for this flow chart, but we're going to go through it in a bit. So if these equations are unknown to you or unfamiliar, or if they're intimidating, don't worry about it. We're going to go through it step by step. So to get from our observed value to our mean, we're going to sum our x observed values, and we're going to divide it by n. Then we're going to use this mean in an equation to get our standard deviation. That looks like this. We're going to take our x observed scores from here, and we're going to minus all of them from our means, or our mean. Then we're going to square this number, or these numbers, and then we're going to sum them up together. Now this equation here is what we call the sums of square. We're going to take this and we're going to divide it by n minus 1. Now in this video I'm not going to talk about this minus 1. We'll leave that for another video. But for now let's just take it for granted that it's n minus 1. And this equation is the equation for variance now. Then the last thing we're going to do is we're going to square root it. And that's going to give us our standard deviation. So moving from our standard deviation to our t-score is going to go through this equation where we're going to use our mean and our standard deviation, and that looks like this. We're going to take our mean, we're going to minus it from our mu. Now in a past video I talked about how the mu is a population parameter. And what that means for students is that it's going to be given to you in the equation, so you don't have to compute the mu like we had to compute the mean and the standard deviation. Then we're going to divide this by our standard deviation, but also that is going to be divided by our square root of n. Now this part here is what we call a standard error. So it does look a little bit confusing, but don't worry about it too much. That's going to get our t-score. Now with a t-score, we're able to get our p-values by using the t-table. And just like a past video, we can also start with p-value and move back towards and get our t-score as well, using that same t-table. So now let's go through all of these equations using an example. The first thing I'm going to do is I'm going to give us this mu. We're not going to use it right away, we'll have to wait for a bit, but like I said, this is going to be given to us with a question. So let's just put this mu as 3 over here. So once we need it, we'll have it there for us. Now also given with the questions is a set of observed scores. So let's say 1, 5, and 9. So participant 1 had a score of 1, participant 2 had a score of 5, and participant 3 had a score of 9. First thing we have to do is calculate our mean. So what we're going to do is let's start off by drawing out this equation again. And what this means is the sum of x. So these are our x values. So we're going to take 1 plus 5 plus 9. And on the bottom indicates how many observations we have. So here we have 1, 2, 3 different observations. So our n is 3. So putting that together, we get 1 plus 5 is 6, plus 9 is 15, divided by 3 is 5. So our mean is 5. Now the next thing we're going to do is we're going to go through this equation to go from our mean to our standard deviation. Now again, this is a complicated looking equation, but it's actually fairly simple. So let's start off with our x scores. They're already here, but let's rewrite them down here. So we have 1, 5, and 9. Okay? Now let's start with the inside. So we're going to do this piece by piece. So we're going to just start with this part here. So let's write a new column. And it should already be obvious based on what the actual notation is, what we do. So we take our x values and we minus by our mean, a mean of 5. So we take 1 and we minus by 5, 5 minus by 5, and then 9 minus by 5. So what we get is -4, 0, and then 4. And that gives us the deviations here. So that's done so far. The next part is to square these numbers. So what we're going to do is we're going to have our x minus mean squared. And so we're going to square that number, and then that number. That's going to give us 16, 0, and then 16. So now what we've computed is this part here. So the next thing we're going to do is we're going to have to sum them all together. So we're going to take our 16, and we're going to plus 0, and we're going to plus 16 again. That's going to give us 32. Now we call this the sums of squares. Okay, so now what we've calculated is this top part. And this is the sums of squared. And that's equal to 32. The next thing we're going to have to do is divide that by n minus 1. Now remember, n corresponds to how many observations we have. So we have 1, 2, 3. So what we're going to do is we're going to divide this by n minus 1, so 3 minus 1. So that's going to give us 32 divided by 2, which means 16. And this is now our variance. And that constitutes this entire equation within the square root. So now we've gone through all of this. So we've found our deviations, we squared them, we summed them together, and then we divided by n minus 1. And that leads us to our variance. The last thing we have left is to actually compute our standard deviation from our variance. And that's just by doing this square root process. So to get our standard deviation, we're going to square root this 16, and that's going to equal 4. And that is our standard deviation. So now our 4 can go up here as our standard deviation. So the next step is to go from our standard deviation to our t-score. And that's using this equation here. So let's start off by rewriting it out here. So our mean, which is 5, minus our mu, which was given to us earlier on as 3, divided by this standard error is what we call it. So it's our s divided by our square root n. Now, this part here can be confusing for some people, and some professors rather write it out like this, so standard error. And then what they'll do is they'll give you this equation separately, and then simplify this equation by doing this. So now you have your mean minus your mu divided by your standard error, where your standard error constitutes this equation here. So we can easily figure out our standard error as our s, which is 4, divided by the square root of our n, so square root of 3, because again, n is how many observations we have. And that equals 4 divided by 1.7321, which then equals 2.3094. So now this is your standard error. We're going to put that at the bottom of this equation. So let's bring this equation down a bit here. And what we get is our mean, which is 5, minus our mu, which was given to us in the question, which is 3 here. So it's going to be 5 minus 3 divided by our standard error, which is 2.3094. 2.3094. So if we do some of that math, it's going to be 2 divided by 2.3094, which equals 0.8660. And this is our t-score, so we can put that up here. So 0.8660. Now we can find our p-value by using our t-score in the t-table. I'm not going to do that here though, because there is a little bit more to it that we need to know, and I'll cover more about t-tests in another video. Now I went ahead and used a program to determine this p-value without using the t-table, and what we get is a p-value of 0.4778. Using the t-table, we might not get a p-value this specific, but we can do the same idea. So altogether, what we did is we started off with some observed scores. And then using this equation, we were able to determine the mean of these scores, and then the standard deviation with this equation. Using both of the mean and the standard deviation, we were able to determine a t-score using this equation, and then using the t-table, we can come out with a p-value. Now, if we started with a p-value, we could also use the t-table to go back to the t-score. But hopefully this is showing the relationship between all of these things that are often overlooked or poorly understood. And now you can see, instead of having a page full of equations, that one equation just naturally leads to the next equation, and so forth.